The first right-hand rule is a method you can use to determine the direction of a magnetic field relative to the direction of conventional current. Imagine holding a length of insulated wire with your right hand. Keep your thumb pointed in the direction of the conventional positive current. The fingers of your hand circle the wire and point in the direction of the magnetic field. An electric current in a single circular loop of wire forms a magnetic field all around the loop. Applying the first right-hand rule to any part of the wire loop, it can be shown that the direction of the field inside the loop is always the same. The magnetic field around a circular field is always up or out of the page. Outside the loop, it is always down or into the page. When a wire is looped several times to form a coil and a current is allowed to flow through the coil, the field around all the loops is in the same direction. A long coil of wire consisting of many loops is called a solenoid. The field from each loop in a solenoid adds to the fields of the other loops and creates greater total field strength. When there is an electric current in a coil of wire, the coil has a field similar to a permanent magnet. When this current-carrying coil is brought close to a suspended bar magnet, one end of the coil repels the north pole of the magnet. Thus, the current-carrying coil has a north and a south pole and is itself a magnet. This type of magnet, which is created when current flows through a wire coil, is called an electromagnet. The strength of the field is proportional to the current in the coil. The magnetic field produced by each loop is the same. Because these fields are in the same direction, increasing the number of loops increases the strength of the magnetic field. The strength of an electromagnet also can be increased by placing an iron rod or core inside the coil. The core supports the magnetic field better than air does. It increases the magnetic field because the field of the solenoid creates a temporary magnetic field in the core, just as a nearby permanent magnet does when brought near a metal object. The second right-hand rule is a method you can use to determine the direction of the field produced by an electromagnet relative to the flow of conventional current. Imagine holding an insulated coil with your right hand. If you then curl your fingers around the loops in the direction of the conventional positive current, your thumb will point toward the north pole of the electromagnet.